Okay, now let's go back and tackle what I mentioned earlier as OR problems. I'm going to pause this video. So as I consider this question, how many have been to St. Louis or Memphis? Let's just ask you guys, and we're going to include me in this, okay? How many of you have been to St. Louis in your lifetime? Get your hand up. I see that's everyone. So all 7 of us have been to St. Louis. How many of you have been to Memphis? Nuts. That's not the town I want to use then. Pause. So I'm changing the town to Indianapolis instead of Memphis. So how many of you have been to Indianapolis? Time out. Indianapolis will work. Robert has been to Indianapolis and so have I, so that's 2 of us. So here's what most people do when they get an OR problem. If they want to figure out how many people have been to St. Louis or Memphis, they count how many's been to St. Louis, they count how many's been to Indianapolis, I should say, and then they add them together. But class, do you see that 9 is an impossible answer for us as far as how many have been to St. Louis or Indianapolis, because there's only 7 of us. We got the 2 in Metro, the 4 in Anna, and I'm here. That's 7 of us total. So how can 9 of us have been to St. Louis or Memphis? What mistake did we make by doing that? Chew on that for a moment.
Repetition.
That's right. What do you mean by that, Chris?
You repeated 2 people.
That's right. I counted Robert and I twice because we're the ones who have been to both. We had been to St. Louis, so we got counted there, and we had been to Indianapolis, so we got counted there again. So we got double counted. Robert and I did. So here's the way that we have to account for that when we have an OR problem. We're going to end up with the following formula. And any time you get an OR problem, I suggest going to this formula, to keep you from making mistakes. It goes like this. The number of ways event A or event B can occur is equal to the number of ways event A can occur plus the number of ways event B can occur minus the number of ways event A and B can occur. So in other words, you add them together like we just did, but then you got to subtract out the ones who have done both because they've been double counted. If we would have used this approach on the last problem, we would have had the number of ways that we could find the number of people who had been to St. Louis or Indianapolis would have been equal to the number that had been to St. Louis plus the number that had been to Indianapolis minus the number that had been to St. Louis and Indianapolis. And that would have been equal to, all 7 of us had been to St. Louis, 2 of us had been to Indianapolis, 2 of us had been to St. Louis and Indianapolis. So 7 plus 2 is 9 minus 2 is 7. And we would have ended up where we needed to be. Okay. Now, let's apply this OR formula several more times. We're going to begin by looking at another card problem. So this is not in your textbook. This is just an example I'm putting up here. And the question goes like this. How many ways can a red card or, there's the word, the 5 of spades be pulled from a deck of cards? So I'm pulling 2 cards, and I want to know how many ways could I pull a red card or the 5 of spades. The key word here is, of course, the word or. And that's going to be a key to this test, is now we got to recognize what kind of problem do we have. Do we have an or problem? Do we have an at least one problem? Or do we have a problem where I'm going to work through my 2 questions? Is repetition allowed? Does order matter? Okay, well this is an or problem, so I'm going to use the or formula, which goes like this. The number of ways I could get a red or the 5 of spades, which I'm going to call 5s. And I'm always going to go to the formula because I'll end up making a mistake if I don't. So that equals the number of ways the first thing can occur, number of ways I could get a red, plus the number of ways I could get a 5 of spades, minus the number of ways I could get both red and 5 of spades. All right, well, let's substitute into that formula then. So, Tristan and Summer, how many red cards are in the deck?
26.
26. Plus, let's stick with you guys. How many 5 of spades are in the deck?
1.
1 5 of spades. Minus, how many cards are both red and the 5 of spades?
0.
0. The 5 of spades is black, isn't it? It's not red, so the 0. Class, whenever you get a 0 back here, that means that the 2 events that we're discussing are called disjoint. Or sometimes you hear the phrase mutually exclusive. And what that means is you have 2 events that can occur at the same time. I can't be both red and 5 of spades. If I said being from Missouri and being from Illinois, well, you can't be both from Missouri and Illinois at the same time, so those events are disjoint. They're mutually exclusive. If I said being from Illinois and being from America, those are not mutually exclusive. You can do those at the same time. So anytime you have disjoint events, this and part back here end up being 0, and so here we end up with 27 total. Okay. What if we change that problem just a hair? What if we said, how many ways can I pull a red or a king? Okay, again, the overriding idea is that we have an OR problem. So we're going to go to the OR formula. So the number of ways I could get a red or a king equals the number of ways I could get a red plus the number of ways I could get a king minus the number of ways I could get a red and a king. So if it's an or problem, go to the formula, then fill in the formula, which Tristan did very nicely on the last problem. I hate to ask Katie because she's still learning about cards. So let's just go to Brandon here. Brandon, how many ways can I pull a red card?
26.
How many ways can I pull a king?
4.
4. There's a king of hearts, a king of spades, a king of clubs, and a king of diamonds. There are 4 kings in the deck. Minus, Brandon, how many cards are both red and king?
2.
What are they?
The king of hearts and king of diamonds.
That's right. So those have been double counted. So red and king, those events are not disjoint because we didn't get a 0 back there. So the answer to our question here is 26 plus 4 is 30, minus 2 is 28. 28 ways I can pull a red or a king. So I want to finish off this problem with a little bit of a challenge problem that's going to require of us to use multiple strategies that we've talked about during this chapter. Okay? So the key here is not to think about too much at once. What I've got on your screen is example 7, but I did not want to have you turn there because it's got the solution right below it, so that takes your thinking away when you're able to see it. So let's see what we got here. How many 3-digit counting numbers are multiples of 2 or multiples of 5? Okay. So moving forward, here's how we're gonna think through things. We're gonna check to see if we have an or problem. I should have used black there. If it's not that, we'll see if it's an at least one problem. And then if it's not that, we'll run through our series of questions. Okay, so that will get us pointed in the right direction as far as what kind of problem we have. Well, clearly, this is an or problem. So the first thing we got to do these problems well is read. We have to figure out what it is that we're dealing with here. And this is an or problem. If it's an or problem, we're going to use the or formula. So what am I looking for here? The number of 3-digit numbers that are multiples of 2 or multiples of 5. So that gives me a place to start. Okay? Now, if it's an or problem, then I got to use the or formula. So that equals the number of 3-digit multiples of 2 plus the number of 3-digit multiples of 5 minus the number of 3-digit multiples of 2 and multiples of 5. That's the big picture to the problem. So that's the way we want to start thinking. What's the big picture first? Don't try to answer every nut and bolt right off the bat. Just say, what's the big picture? What am I after? This is what I'm after. Okay, now I've got 3 smaller problems. I've turned this into 3 problems. And the first problem is, how many 3-digit multiples of 2 are there? Okay, so we have done several problems like this by now. So let's think. Now we're going, that's not an or problem when I just ask how many multiples of 2. It's not an at least one. So I'm going to go through my line of questions for that. Okay? Well, is repetition allowed? So class, with my 3-digit counting numbers, is repetition allowed or not? This is a reading problem right now. Is there anything in that problem that tells you that repetition is not allowed? No, there's not. So repetition is allowed. And if repetition is allowed, then we're going to draw blanks. Okay? Now, if I'm going to be a multiple of 2, then that puts a restriction on the last digit. So I'm going to consider the last digit, then the first digit, and then the second digit. A multiple of 2 would have to be even, so it'd have to end in either 2, 4, 6, 8, or 0. So there's 5 ways it could occur. As we discussed the other day, the first digit could be anything except it can't be 0. I can't have a 3-digit number that starts in 0. So there are 9 ways it can happen. And there's no restriction on the second digit. So there's 10 ways it can happen. So 5 times 9 times 10 turns out to be 450. So there's 450 3-digit multiples of 2. Okay. Now let's go to the 3-digit multiples of 5. That's my second problem. I'll do it in blue. So, is repetition allowed? Yes, so I'm going to draw blanks. If I'm a multiple of 5, then there's a restriction on the last digit again, so I got to do it first, then do the first digit, and then the second. Class, if I'm a multiple of 5, then how many choices do I have for the last digit?
2,
What are they?
0, and 5.
That's right. I got to end in either 0 or 5. So 2 choices for the last digit. Still 9 choices for the first digit, everything except 0. And 10 choices for the second digit. And 2 times 9 times 10 is 180.
How did you get 2?
Well, if I'm going to be a multiple of 5, then the last digit in my number has to end in either 5 or 0.
Okay, never mind. I thought it said on for some reason.
Okay, and then let's look at this last one. How many 3-digit numbers are multiples of 2 and multiples of 5? Well, is repetition allowed? Yes, it is. So I'm drawing blanks again. If I'm going to be a multiple of 2 and a multiple of 5, that's going to put a restriction on the last digit. So I'll go last, first, second yet again. Class, what does the last digit have to be if I'm both a multiple of 2 and a multiple of 5? Think about it. If I'm a multiple of 2, then the last digit has to be 2, 4, 6, 8, or 0. And if I'm a multiple of 5, my last digit has to be 5 or 0. So if I'm a multiple of both, the last digit has to be 0. That's the only thing it can be. So there's 1 choice for the last digit, 9 for the first digit, and 10 for the second digit. Which makes another 90. And so now 450 and 180 is 630, and 630 minus 90 is 540 3-digit numbers that are multiples of 2 or multiples of 5. Now that sure beats listing them all out. Takes some thinking, but once we do the thinking, it kind of makes sense. Now, let me just tell you up front, this is an assignment that's a lot of students have trouble with. So if you struggle on some problems here, that just makes you normal. Don't freak out. Get the ones you can get. The ones you don't get, ask about, get some help on, then go back again. Okay? So, here's your assignment for Chapter 10, Section 5. It's page 572, 3 through 15, and 27 through 32.